Let us look at this 7 segment display unit now, and the name comes from the fact that there are 7 segments: 1, 2, 3, 4, 5, 6 and 7, and each segment can be either lit or it can be dark, and that depends on whether this diode conducts or does not conduct. So each segment has this diode, which is a light emitting diode or LED, and that can be either on or off. If there is a forward voltage across this diode, then it would conduct and it would emit light, and we will see that segment in that case as lit. If not, then the diode does not conduct and the segment will appear as a dark segment. These segments are given names. For example, this one is called A, this one is called B, C, D, E, F and G. And each segment of course is a diode, as we mentioned earlier. And the P terminal of each diode, that is the anode, is connected to the power supply. So they're all tied together, all of them, and they are connected to the power supply VCC, which is 5 volts. And the other end, the N end or the cathode, is made available as a pin of this display unit. So this one is called A bar. This one, the N terminal of that diode, is called B bar. This one, the N terminal of the C diode, is called C bar, and so on. Notice that these pins are active low, and that is why they are denoted by A bar, B bar, C bar, etc. And there is a good reason for that, of course. Suppose this voltage is high, or VCC, what would happen? The voltage across this diode would then be 0, because this end is high and this end is also high, and therefore this LED would not light up, would not emit light. If this end is low, that is active, then this LED would conduct and then the segment would light up. So that is why these pins are active low. Alright, here are some patterns. If our input, if the binary input is 0, 0, 0, 0, then we would like all of these segments to light up here. If it is 0, 0, 0, 1, then we would like these two segments to light up, and so on. So what we need now is a decoder which will take this binary number as the input, and it will produce these 7 outputs which we can use to drive the display unit. And let us now look at such a decoder. Let us now look at a BCD to 7 segment decoder such as the IC7446. Now we should mention that these ICs are specific to the type of display unit they would be driving. This one, for example, is the common anode type. That means all the anodes or P terminals of the diodes are connected together here. We also have the common cathode type display units, in which all the cathodes or the N terminals of the diodes are connected together, and in that case we would be using a different IC in this place. Okay, so let us try to understand the functionality of the 7446 decoder now. What is our overall objective? We have a binary number such as 0001, which is a part of a BCD number, and if the number is 0001, for example, then we would like to see this pattern on the 7 segment unit over here. So what that means is that we must have segment B and segment C light up, and all the other segments must be dark. And how can we make a specific segment light up? We need to turn on the corresponding LED. For example, if we want this segment to appear bright, then this LED must conduct. And when these LEDs conduct, the voltage drop across them is not 0.7 volts like we used to take for a silicon diode, but it is more than that. It could be 2 volts or 3 volts depending on the color. Let's say this is 2 volts. So we must provide a voltage drop of 2 volts here, and that is done by making this B bar low, say 0 volts. So the current path now is like this. We have 5 volts here. Of that 5 volts, 2 volts will drop here, and then 3 volts will drop across this resistor, and that is 0 volts. Alright. Now this resistor serves a very important purpose, and that is to limit the current. And we can make a simple calculation. Say our VCC is 5 volts and VD is 2 volts, and we want to limit the current to 10 milliamps. We know that this voltage drop is 3 volts then, so the resistance must be 3 volts divided by 10 milliamps, that is 300 ohms. How can we make a specific segment appear dark? We can do that by making sure that the corresponding LED does not conduct. For example, if this segment has to appear dark, then this LED should be turned off, and we can ensure that by providing a high voltage at this B bar pin, say 5 volts. So then we have 5 volts here, we have 5 volts here, and then the total voltage drop across B, the diode B, and this resistor is 0, and therefore there is no possibility of any current. The LED is off, and therefore the segment will appear dark. Alright, now we understand what this 7446 decoder must do. For example, if we want this pattern to appear on the 7 segment display unit, then we must have this segment light up and this segment light up, and in that case we must make B bar low and also C bar low, because the segments to light up are B and C, and all other outputs here like A bar and D bar and so on must be made high. So that gives us the truth table for this 7446 decoder. Now of these various patterns, as a user we only care about numbers up to here. That means binary numbers from 0000 to 1001, because in our BCD number we are not going to encounter any of these binary numbers. However, manufacturers of 7 segment units use these patterns for some kind of authentication, and therefore these patterns are not arbitrary, they are fixed. So for 1010 we do expect this pattern, although as a user we do not use that, and therefore we have the entire truth table now for all combinations of A, B, C, D, with D as the MSB and A as the LSB. So we can prepare a truth table with all possible combinations of the inputs A, B, C, D, and for each combination we can figure out whether a given output such as A bar should be high or low. And once we do that, then we can figure out what logic can implement that function. And that brings us to this homework. Write the truth table for C bar, that is this output here, in terms of D, C, B, A, and then obtain a minimized expression for C bar using a K-map. Let us look at the 7442 BCD to decimal decoder. Its input is a 4-bit binary number with A3 as the MSB and A0 as the LSB. So the input numbers will range from 0000 to 1001, that is decimal 0 to decimal 9. There are 10 output pins, and notice that the output pins are active low from O0 bar to O9 bar, and corresponding to the decimal number that appears here, one of these output pins will be made active and all others will be made inactive. Here is the truth table, and we are only listing the active output in this column. When A3, A2, A1, A0 is 0000, then O0 bar is the active output. When it is 0001, then we have O1 bar as the active output, and so on, all the way up to 1001. And for this combination, O9 bar is the active output. And these combinations are not expected to occur because we are talking about BCD numbers here. So our input binary number is going to correspond only to decimal numbers from 0 to 9. So in these cases, none of the output pins is made active.